My name is zhuo, and today I will show you my final report. My report project is the realization of digital recognition rider based on deep learning of neural network. Because recently, handwriting recognition is widely applied in computer vision. The process that machine automatically interpret handwriting characters and digits is called handwriting recognition. And there are already member of classic method and algorithm to solve this problem like KNN, SK, RBF, and polynomial and linear SVM. And the deep learning neural network is one of the most popular modern methods. It can let the computer to learn from the real data to solve the speech and the image recognition problems. And in my project, I will deal with the data from famous data set, which is called MNIST. With the help of TensorFlow mode from the Python, my neural network system can deeply learn from the training example to develop the rules and to recognize handwriting digits, which when the number of training example is increasing, the accuracy of system would increase and improve. The method had produced nearly around 19.5 to 19.6 accuracy, and more than 2,500 learning steps, which is better than the classic approach. And this is the picture show the handwriting digit. The main difficulties of it is that the huge deals of writing styles, we need to reduce the differences in the one class when we classify the pattern from the great number of data. And also we have the two difficulty is that between different club patterns, we have some ambiguous, such as the 1 and the 7, 8, and 9. Those two patterns will make the ambiguous. So how to decrease ambiguous between the different classes is also a problem. So HDR problem is a perfect prototype problem for neural network learning because there are only 10 patterns and do not need a very large repeated computational time and power. And here is my scheme for my project. First, I use the training data set, and after data processing, and then I put them into the neural network to let my neural network to learn from the training data. My neural network has first layers, connected layers, and second layers. And after the neural network finish learn from the training data, I put the test data and into the data processing part, and then put into my neural network to let my neural network to make prediction. So the whole project contains 5 parts. The first part is the setting and libraries of Python. We need to improve 5 models, 1, 2, 3, 4, 5, and set parameters such as learning rate, training literature times, and dropout, and branch size, and visualization size, and display the image. The second part of my project is data preparation. It's like data processing part, and we should read the training data in the CSV file, and we need to convert the image from the 0 to 255 to 0 to 1, and we need to change all the images to square, and also I need to display the images and get the class labels and convert them to one hot vector, and then I will need to split training data into 2 parts: is training data and the visualization. And I can show you in my code how I finish those parts. You can see that it is my code. This the import part, and this is setting part. And then I start to read the training data from CSV file. It's already in this part, and I convert image to square is in this part, and then I display the image is in this part, and then I separate the training data into two parts is in this part. So I already finished that. And the third part is the neural network structures. It's need to initialize weight and bias. It has those function to build the 5 layers in the neural network. We need to build convolutional layers, build connecting layers. We need to build the pro layers. We need to we visualize them. And you can see this is how I finished in the code. It is a weight initializing part. It is a conventional function. It's a polling function, and it is the input and output of an function. It is the first conventional layer, and this is how I prepare for the visualization. And in the later you will see the result of visualization of the first conventional layers. You will see the outcome of this lately in my demonstration. And then this is the second convolutional layers, and also is the connecting layers, and it is a dropout function, it is a cost function, it is optimization function. And the fourth part is the training and the vitalization part. I use a statistic training method to, and if I need to use this method, I need to finish the branch function. It says choose the branch from the data, and start TensorFlow and training and get my final accuracy. You can see it is already done here. It is the branch function, and it is a prediction function, and I will show you later in the prediction function. And the last part, yes, is the prediction. Is I read the data, the test data in CSV files, and after the data processing part, and I will get the result. So it is code, and you can see that this is how I use the TensorFlow. Start the TensorFlow session to build my neural network, and this is the whole, and this is the tested data part. You can see in my code I already finished it. So I will show how mode I used in my project. First, I use the neural mode like this. It is a step function, but in reality we cannot create so good step function, so we use signal function like this to build neural models. But in reality, we have so many neurons in the neural networks, and I decided to have 3 layers, just as I show you in this picture. And the first layers contain the 784 neurons, because it has 28 and 28 times 28 in the first layer, because the picture we already convert the size of it is, as you can see, is 28 to 28. So the first input layer should contain those neurons, and there is a hidden layer in the network, which is the connected layers, and the third layer is output layer, which tells us which member of the image represented. But here we have a problem, because the first layer has too many neurons. So I recommend me myself to use the convolutional neural networks here and to make the heavy lifting, because each layers of CNN contains three-dimensional space to store neurons. We use the widths, heads, and the dips to describe the space to make things easier. So in my convolutional layers, it calculates output of neurons by doing a dot product in three-dimensional size volume, and it needs four parameters, and it's produced the three-dimensional size volume too. And in my neural network, I need to have a pooling layers. It's a downsample sampling operation. It reduces the size of presentation in order to decrease the number of parameters and shrink the computational time. And I have the connected layers, and after pooling layers, image of size is reduced, and we need to fully connect them. And I also have the drop out action to prevent overfitting. And I also have the softmax layer to make the outcome softer. And you can see in my code, as I showed you before, I already finished all the part of those functions. You can find them here in my neural network part. You can find them. I already done that. And the evolution part, I use the cost entropy to evaluate system, because it is more easier, and ADAM optimizer is already built in TensorFlow. So you can see in my TensorFlow part, I already finished that. So this part already done the function here, and finally we need to validation and a test part, and I should use all the data, but it's cost too much time. So I want to make things easier. So I make creativity things is that I choose random data to pick small branches from them, which is stochastic training. And stochastic training gives the same result in short time to make the things easier, but we have the pretty much good result. And I already finished that in my code. Yes, you can see that it's already done here. So then I will run the code to show you how it works. I recommend you to use Anaconda. It's good for Python, but I use a terminal because it's faster to show you how it works. Let's start. Okay, it's run very weird. As we can see from the first part, you can see that the reading training data that we output the data. You can see the data side up here. So I already finished the reading training data part, and then we need to convert image size from this to this, and you can see the outcome of this is already convert the size of image to the 28 times 28, and then I print the labels of members of labels. You can see here I already finished that. It is 10 labels, so from 0 to 9 the 10 labels. So when we make the accuracy rate, we can compare the outcome of the results compared to the predict compared to the labels. If the outcome is the same with the labels, we think the result is correct. If our result is not equal to the labels, we think it is wrong. So you can say my program is still learning. You can see it is from the first step 0 to now it's already learned like 200 step, and you can see the training accuracy divided violation accuracy is like here, so it shows the accuracy for the step 200, because it will take a lot of time because I already have like 2,500 steps, so it takes time. So I will just show you directly in the PPT and show the results. You can see after 2,500 step learning, my program will put a violation data picture directly show the result. As you can see, the training data is the blue line and the green line is violation data. And you can see after we prepare each outcome with the label, I already built in the program, and you can see after 2,500 learning steps, the accuracy of visualization is above the 95, so it is a pretty good result. And do you remember that I say that I will show the visualization part of the first convolutional layers, and this is the outcome, because you can see that this is the outcome. It's a pretty good outcome, so it is shows that how it's work of my neural network, and you can see this, and also you can see I have successful finish the first part, and then I will show you the result of the testing part. You can see that this is the picture that input from the data set. It is 5, and you can see after I input this into my neural network, it shows the result. It tells you that my prediction labels is 5.0, so it is 5. So 5 equals 5. So it shows the result is good. It's correct. So this is how the test part working. And in my project, I realized the digital recognitions by the deep learning of neural network and make creativities use the statistic training way to reduce the amount of training data while maintaining the accuracy. These advantages will become more clean as the training data set continue to increase. And that's all. Thank you.